All right, here's our introduction to logarithms. Shouldn't be an introduction. You should have had nouns too, but we all know how that goes sometimes. So let's take a look here at what we're going to talk about. So first, a logarithm is an inverse of an exponential function. You know that y equals a b to the x is the basic form that we talked about. We read that y equals a times b to the x power. Then, if that's true, then x would equal log base b of a. Again, I read that x equals log base b of a. And that is specific and that is special that you say it that way. So first off, let's take a look at some of these and convert them to logarithmic form using that idea. All right, so basically the idea would be that the exponent becomes the answer and the answer becomes the logarithm. The base stays the same. So 4 squared equals 16 changes to 2 equals log base 4 of 16. The exponent of 2 became the answer of 2. The answer of 16 became the log of 16. The base stays the base. Okay, so 3 to the 4th power equals 81 would say 4 equals log base 3 of 81. M to the n power equals p would tell us that n, the exponent, becomes the answer, equals log base m, base stays the same, okay, of p. The answer became the logarithm. All right, again, that makes sense because we're talking about inverses here, so the answer becomes the problem. The problem becomes the answer. Let's take a look at some more examples. So 2 to the 5th equals 32. Convert that to logarithm form. So that would say 5 equals log, the base is 2 of 32. 1/10 is now the answer. That's going to equal log base 1024 of 2. Negative 3 is the answer. That's going to equal log base 4 of 1/64. So we're just switching, we're converting. We're taking the exponent and making the answer. We're taking the answer and making it the logarithm because they're inverses of each other. If I wanted to convert out of logarithm form, I could. Now I'm going to take the base. 5, the answer becomes the exponent to the 3rd power equals 125. 7 to the 2nd power equals 49. 16 to the 1/4 power equals 2. Just converting back and forth. What if we have to solve these, okay, logarithms? Well, we take a look at this and I say, okay, well, in my head, I know what log base 2 of 8 is, okay? And how do I know that? Well, I'm thinking 2 to what power, that's my answer, is going to give me 8. Well, that would be 3. 8 to what power gives me 2? Okay, and that would be the 1/3 power. What is 3 times 1/3? 1. All right, what about over here? 3 to what power gives me 9? That would be squared. Oops, 9 squared. 2. 9 to what power gives me 3? That would be the 1/2 power. So 2 times the 1/2 is also 1. Then we take a look down here and we have log base 10 of 10,000. So 10 to what power? Okay, would give us 10,000. Okay. Now log base 10 obviously is one that you could use your calculator for if you're unsure of that. Okay, but you could also just, if you understood the metric system, it would be pretty easy to know that there's 4 extra zeros here from 1, so we end up with 4. So now we have log base 2 of 4. Log base 2 of 4 is 2, because 2 squared is 4. And then I have log base 4 of 2. So 4 to what power gives me 2, and that would be 1/2. So ultimately the answer to this is 1/2. And you do have to know a little bit about logarithms to solve this. There's no sort of plug and chug to get your calculator answer. Same thing here. Start from the inside and work out. 2 to what power gives you 8? 3. What is log base 3 of 3? Well, anytime you take the log that has the same base as its number, you get 1 every time. Okay, so 3 to the 1st power gives you 3. What is log base 5 of 1? So 5 to what power gives you 1? And the only power that does that is 0. Okay, any number raised to the 0 power always gives you 1. So the answer for number 9 is 0. I'll see you tomorrow.